Hey everyone, we're going to be working through the Unit 3 review. Okay, we're just going to work on those ones that I told you to worry about and not worry at all about the ones that I told you not to worry about. Alright, so let's go ahead and dive right in. Number 1, given that vector u is equal to 5i plus 4j and vector v is equal to 2i minus j, determine 2u minus v. So what we first need to do is substitute u in for u. We need to substitute this 5i plus 4j in for u, and we need to substitute this 2i minus j in for v. So we have 2 times, so I'm going to put in parentheses, 5i plus 4j, okay, minus, and I'm going to put v in parentheses as well. The reason I'm putting v in parentheses is because a lot of us will forget that this minus sign on v distributes to everything in v. So by putting v in parentheses, maybe that'll help remind us, okay? So we're going to distribute the 2 into everything. So 2 times 5i is 10i, plus 2 times 4j is 8j, okay, minus, okay, so that minus sign is going to change a positive 2i to being a negative 2i, but it's changed a negative j to being a positive j. Okay, now we're going to put like terms together. 10i minus 2i, that's 8i. 8j plus j is 9j. And there we go. That's all that's needed for that problem. That is our answer. Okay, so that means that 2 times vector u minus vector v is the new vector 8i plus 9j in linear combination form. All right, let's move on. Let's try to do problem number 2. Same idea, but what we've done this time is we want 2v minus u. So just here, we're going to say 2, ooh, that's kind of small. Let's make this a little bit of a bigger font here. Sorry about this. Okay, so 2 times v, okay? So v, which is 2i minus j, and then minus u, which is 5i plus 4j, okay? So we need to distribute the 2 in. So 2 times 2i is 4i. 2 times negative j is negative 2j. Minus, this goes to both, so it becomes minus 5i minus 4j. So now I just put like terms together. 4i minus 5i is negative I. You can say negative 1i if you want to as well. And then negative 2j minus 4j is negative 6j. And there we go. That's our answer. All right, so let's go on to number 3 here. Number 3 says find the component form of vector v if the magnitude, you got to remember that's what the double lines mean, they mean magnitude. If the magnitude of vector v is 6 and the angle it makes with the x-axis is 60 degrees. So you should remember that to find, I don't like this font, there we go. That to find the component form, you have to find 2 components. A horizontal component, which I'm going to call h, and a vertical component, which I'm going to call v. All right? To find the horizontal components, just simply h is equal to the magnitude times cosine of your angle. Okay? So then for this problem, h is going to be equal to 6 times cosine of 60 degrees. Now, cosine of 60 is on your trig chart. So you pull up your trig chart and you will see that cosine of 60 is equal to 1/2. And then 6 times 1/2 is 3. And there we go. That's how I find the horizontal component. The horizontal component is 3. The vertical component is the same idea. It is equal to the magnitude times sine. That's the only difference. That's the only difference for this problem, times sine of the angle. So then for this problem, magnitude is still 6. Angle is still 60. So now I just need to grab my trig chart and look up and see what is sine of 60 degrees. So I'm grabbing a trig chart. Sine of 60 is square root of 3 over 2. All right, so it's kind of a weird one. So it is square root of 3 divided by 2. All right, I'm going to write that out. So that's that guy right here, square root of 3 divided by 2. All right, so when you say 6 times this, well, 6 would go to the top. So now we have v is equal to 6 square roots of 3 all divided by 2. And the 6 and the 2 get to cancel each other out, and we get 3 square roots of 3. That's a 3. Square roots of 3. So then, in the component form, it's a sideways, angle. is 3, comma, 3 square roots of 3. And there you go. That's the answer number 3. Number 4, determine the horizontal and vertical components in feet per second of the velocity of the ball thrown with initial velocity of 70 feet per second and an angle of 40 degrees. All right, this initial velocity of 70, that is your magnitude. All right, at an angle of 40 degrees above the horizontal, that is your angle. All right, because guys, look here, what are we doing? We're doing the same thing we just did. We're determining the horizontal and vertical components. So it's the same problem. We know that the horizontal component is equal to the magnitude, which is 70 in this problem, times cosine, I should have typed this out, of the angle, which is 40. So 70 times cosine of 40. So this is a calculator problem because cosine 40 is not on your trig chart. So you will have to use a calculator. Check your mode real fast. I'm in radians. I don't want to be in radians. I want to be in degrees because my angle is given to me in degrees. So now I'm in degree mode. So I just say 70 cosine of 40. Press enter, and I get 53.6. So 53.6. Then I can do the same thing to get the vertical component. I can say V is equal to 70 sine of 40. All right, and once again, we're just going to grab our calculator and do that problem. So we're going to say 70 sine of 40. Press enter, and we get 44.995, which I'm going to round to being 45. So then, in component form, it is 53.6, comma, 45. So our horizontal component was 53.6, and our vertical component is 45. Good. Let's go on. Number 6 and 7, because we need to do number 5. Eliminate the parameter and write the corresponding rectangular equation. All right. A rectangular equation is only dealing with x and y. So we want to get rid of t and make just an x and y equation. So here's how you do it. Go to the x equation. Solve for t on the x equation. So right now x equals t plus 3. I want to get t by itself. That's what it means to solve for it. So I need to subtract the 3 over. So x minus 3 is equal to t. Now I want to take this x minus 3. I want to plug it in for t right here. So y is equal to x minus 3 squared. So all I did was substituted x minus 3 in for t. Now I need to actually square this out. So it's helpful to remind yourself, what does it mean to be squared? Well, it means that I'm multiplying this thing by itself. Okay, so now we have y equals x minus 3 times x minus 3. So then we do first times first. So x times x is x raised to the second power. I'm trying to refresh my memory on where all these buttons are. X squared, okay. Then we do x times negative 3, which is negative 3x. All right, so I've done first to first, first to second, so now I can go to the second term of the first one. Negative 3 times x, which is negative 3x. And negative 3 times negative 3, which is a positive 9. Oh. So now I just need to combine any like terms I have. So y is equal to x squared. There are no other squares. Minus 6x plus 9. And that's it. That's all I need to do for this problem. So now we're going to go do the same idea on number 7. Okay? It says x is equal to t over 3. So we just need to multiply both sides by 3. All right, 3 times x is just 3x. And t over 3 times 3, the 3's get to cancel. So you get just t. So now we know that t is equal to 3x. So if y is equal to 1 over t, I can substitute in this t for 3x. So y is equal to 1 over 3x. And that's the answer. I'm done. There's no need to do anything else. There's nothing else you can do. So there you go. All right, let's move on. Okay, so our next two problems are 12 and I skipped number 8. We'll circle back to number 8 at the very end of this video, okay? I just realized that I skipped it. So we are going to circle back in at the very end of the video. I apologize for that, but I just looked at it and realized I skipped it, okay? So let's go on to number 12. given a point in polar coordinates, convert the point to rectangular coordinates, x, y. So basically, this is a polar point. So that means this is r, and this is theta. All right, and I want to change it to being an x and a y. Well, you should remember that to find this, you can find the x is equal to r times cosine of theta, and y is equal to r times sine of theta. All right, so then for this problem, x is going to be equal to -2 times cosine of 7 pi, I need to get a tablet so I can write better, over 6. All right, so -2 cosine 7 pi over 6. Cosine of 7 pi over 6 is in your trig chart, so you can just go pull it up and you'll see that it is equivalent to cosine 7 pi over 6, negative square roots of 3 over 2. Negative square roots of 3, all divided by 2. Okay, so we're going to multiply -2 times negative square roots of 3 divided by 2. The negatives will cancel each other out. The 2's will cancel each other out. So you're just left with square roots of 3. All right, so now I'm going to repeat this process, but just simply for y. So y is equal to -2 times sine of 7 pi divided by 6. So I grab my trig chart and I go look up and I see that 7 pi sine of 7 pi over 6 is -1/2. So I still have this -2 out front, but sine of 7 pi over 6 is equivalent to -1/2. So -2 times -1/2, well, the negatives cancel each other out, the 2's cancel each other out, so we're left with just 1. So then that leaves us with the rectangular point square roots of 3, 1. And there we go. All right, let's do number 13. I'm going to erase this because I need a little bit more space. But let's try doing number 13. All right, so number 13 gives me the polar point 2, 5 pi over 4. We're going to do it the exact same way. So once again, refresh that this is your r and this is your theta. And we can find x by saying r times cosine of theta. And we can find y by saying r sine of theta. Okay? So then for this problem, we know that x is equal to 2 times cosine of 5, and I do believe that there is a symbol pi in the Greek. 5 pi divided by 4. All right, so I look at my trig chart and I see that cosine of 5 pi divided by 4 is equivalent to negative square roots of 2 over 2. So negative square roots of 2 over 2. All right. So when you're multiplying this 2 times negative square roots of 2 over 2, the 2's, the one here that's on top and the one here that's on bottom, will get to cancel. So we're going to be left with x equaling just negative square roots of 2. Oh boy, my handwriting is bad. All right. So now we need to go to the same thing, but with y. Okay. So we can look here and see, well, we're just going to write this all out. Y is equal to 2 sine of 5 pi over 4. Okay, so I look at my trig chart and I see that sine of 5 pi over 4, so I go to the sine column, I find 5 pi over 4 on the left side, it's the same thing, it's negative square roots of 2 over 2. So once again, I know that the 2 right here and the 2 right here will cancel, so I'll be left with just y equals negative square roots of 2. So then my final answer is the rectangular point negative square roots of 2, comma, negative square roots of 2. Okay? Let's move on. 14. Given a point in rectangular coordinates, convert the point to polar coordinates. So this is not an r and a theta, this is now an x and a y. All right. Okay, so sorry about that. I maxed out on my time limit. I wasn't paying attention. So we were on problem 14. This was an x and a y, and we need to change to an r and a theta. So I was saying you should remember that r is simply equal to the square root of x squared plus y squared. Okay? So r should be pretty easy to find. And then you should remember that theta is equal to the tangent inverse of y over x. You know, let's not think about it like that. Sorry. Let me back that up. Let's think about theta as being tangent theta is equal to y over x. Because we might be able to just look at our trig chart rather than having to use some weird tangent inverse. So let's think about it as tangent theta is equal to y over x. Okay, so let's start off finding r. R is very simple to find. It's just simply equal to the square root of x squared plus y squared. So in this case, it's equal to the square root of 1 squared plus 1 squared. Now, I'm going to write it out, but hopefully most of y'all like 1 squared is just 1, and 1 squared is just 1, and 1 plus 1 is just 2. So you should be able to quickly say, Miss Dillon, r is just going to equal the square root of 2. And you can't break that down. You can't simplify square root of 2, so then that's what r equals. It equals square root of 2. So now let's find theta. So we find theta by first finding tangent theta. All right, tangent theta is equal to y over x, so 1 over 1, and 1 divided by 1 is just 1. Excuse me. So tangent theta is equal to 1. Okay, so in our trig chart, if you take a moment and look at your trig chart, you go to the tangent column, you'll see that it equals 1 at 2 places, at pi over 4 and at 5 pi over 4. So what you have to do is ask yourself, okay, which one of these is the correct angle that I want for this problem? Well, just simply ask yourself, where does this point 1, 1 fall? What quadrant does it fall in? Does it fall in quadrant 1, quadrant 2, quadrant 3, quadrant 4? Well, x and y are both positive, so that's quadrant 1. So then, tangent, we need this tangent angle to be in quadrant 1. So which angle, pi over 4 or 5 pi over 4? Which one of those puts you in quadrant 1? Pi over 4. So then we know that we need theta to be pi over 4. So we know then our point is the polar point square root of 2, comma, pi over 4. All right, so there you go. That's how you do that problem. Let's try 15. Okay, so 15 is the x and y point, -1 square root of 3. So once again, I already know how to find r. I know that r is just simply equal to the square root of x squared plus y squared. So that's going to be a -1 squared plus a square root of 3 squared. Okay? -1 squared is just 1, and square roots of 3 squared is just 3 because of the square root sign and the square sign right here, because this square sign is only applying to this square root sign. So these cancel each other out, so you're left with just 3. And hopefully you can see that this is going to be the square root of 4, because 1 plus 3 is 4. And hopefully you're like, oh, Miss Dillon, the square root of 4, that is just simply 2. Alright, so now let's find theta. So we say tangent theta is equal to y over x. So square root of 3 divided by -1. Square root of 3 divided by -1. And hopefully you're like, dividing by -1, that would only just change the sign. So I know that tangent theta is going to equal negative square roots of 3. So now you can go grab your trig chart and you can look and see where is tangent theta equal to negative square roots of 3. And we see that's equal to in 2 places, at 2 pi over 3 and at 5 pi over 3. So you have to ask yourself, which one do I want? Well, ask yourself, where is this quadrant? Where is the quadrant, this point that we're working with? What quadrant does it fall in? -1 square root of 3. Take a moment, think. What quadrant does that fall in? X is negative, y is positive, quadrant 2. Okay? So then, I need the angle that falls in quadrant 2. So ask yourself, which one falls in quadrant 2? 2 pi over 3 or 5 pi over 3? 2 pi over 3 does. So I know that theta is going to equal 2 pi over 3. So then I know I have the polar point 2 comma 2 pi over 3. And that's my answer. Alright, 16. Be able to graph with a graphic calculator and identify the type of graph. Alright, so these are both polar because they have r's and thetas. If we have polar and we're asked to graph, the first thing you need to do is go to mode and change yourself to polar mode. So I'm now in polar mode. Then go back to y equals. So it should say r1, r2, r3, etc. And we want to say negative 3 theta, that's this button right here, divided by 4. Alright, we hit graph. Now, right now my graph looks weird. Here's how you want to do it. You want to hit zoom 6. Okay. Then you want to hit zoom 0. And then you want to hit zoom 5. Now this is kind of excessive for this specific problem, but you should really learn all those. Zoom 6, zoom 0, zoom 5. This is a spiral. So my answer is just simply spiral. Okay, let's do 17. Wait, that's not what I meant to go to. Sorry, my apologies. 17, which is 3 sine theta. So 3 sine theta. Ah! Hit graph, and we want to follow that same pattern again once it gives me a chance. Zoom 6. Don't take any guesses yet. Follow the pattern. Zoom 0. And then, because right now you're probably tempted to say an answer that might not be correct. So follow it up with zoom 5. And that's clearly a circle. So you're going to type in circle. Okay. 18. Determine the equation of an ellipse with the horizontal major axis is 16 units long, centered at 5, 4, and the minor axis is 9 units long. Okay, so what you got to do here is you got to remember that ellipse equation is simply x minus h divided by, oh, I forget exactly how I label it down here. But basically it's the axis, the horizontal axis. Okay, I forget what letter I put, so I'm just going to put a. A squared, because that's A stands for your horizontal axis. Okay, so once again, A represents half your horizontal major axis. And I think I just realized, so I paused this video. I know this is weird because also I'm changing courses. But I just paused this video and I realized that I don't think I've ever told y'all to half your axes. So you're supposed to half and then square your axis. I think beforehand I made a mistake, and I'm going to clean that up, and I'm going to talk to y'all about it in class. But I made a mistake, and I don't think I ever told you to half your axes. I think I told you to just simply take your axis and square it. And that's a mistake on my part. You need to half your axis and then square it. A stands for half of your horizontal major axis. Okay? So this is an ellipse, so you put a plus sign in the middle. And then it's y minus k, okay, I forgot to put my squares here, y minus k squared, and x minus h squared, all over, and this would be b squared. So once again, you need to half. B just stands for the vertical axis, okay, which might be the minor axis in this case for this problem, all right, but b just stands for your vertical axis, and that's just equal to 1. Okay, so once again, you need to half, then square your axes. I just went back and looked at your Canvas quiz, and I made that mistake. I just totally forgot about it before Christmas when we went over this before. I mean, this is my fault, okay? So I'll make sure I talk to y'all about this in class today, but A and B, you need to half your axes, okay? So then the rest of this problem is pretty simple. H is just the x value. Y is just the k value of the vertex. H, k are just the x and y values of the vertex, okay? So it's the center. Okay, so you would just say x minus 5 squared over. Now, this is the part I apologize. I forgot to tell y'all to half your axes. Okay, I was just working on this. I was working the review, and I realized, oh yeah, I need to make sure I half my axis. And I thought back, and I thought, I never told them to half their axis before Christmas break. Okay, so with your notes, some of you guys, I saw y'all took great notes over that quiz. I feel so terrible at the moment. Make sure you half your axis and then square it. So the horizontal major axis is 16, so you need to take half of that, which is 8, and you need to square that to get right here. So I'm just going to go ahead and put 8 squared, but then I'm going to actually write it out. So you're going to get 8 squared plus, and that's going to be y minus 4 squared, all divided by, once again, this is your minor axis, so you need to take this 9 and cut it in half. So 3 squared is equal to 1. And the last step you're going to want to do is actually just square out your denominators. So it's going to be x minus 5 squared, all divided by 64, plus y minus 4 squared, all divided by 9, is equal to 1. Alright, and so that's your answer. Once again, guys, remember to half your axis and then square. Okay? I genuinely apologize that I forgot to do that for you. That's what you need to do. You need to take half your axis and then square it. Alright, let's move on. Problem 20. Alright, 20 and 21, guys. These are the problems that you just kind of got to memorize your answers to. Sorry, I'm trying to find a piece of paper. You've just got to... What did I do with that paper? You've just got to memorize these answers, okay? The sum of all points in a plane, the sum of whose distances from two distinct points is constant, okay? So it says the sum of whose distance from two distinct points is constant. That is an ellipse. That is an ellipse. All right? The set of all points, the difference of whose distance from two distinct fixed points is constant, is a hyperbola. Once again, you just have to memorize these answers, guys. These are just basic definition questions that you're just going to have to memorize the answer to. Okay? 23. The intersection of a double nap cone and a vertical plane which does not intersect the vertex of the cone. All right? That is also a hyperbola. Okay? So, a key thing here. Make sure you're memorizing this, but it says the intersection of a double nap cone and a vertical plane which does not intersect the vertex of the cone. Okay? That is a hyperbola. You got to make sure that you're noticing that a hyperbola does not intersect. Alright? That is key. That is key, that is key, that is key. That's something that you have to remember. Okay? So, problem 26. The graph of the set of parametric equations, x equals 4 sine t and y equals 4 cosine t, represents a or an. Here's how we do this. We grab our calculator. Now, it says parametric, so we need to go to parametric mode. So we need to turn it on. My calculator would turn on. Sometimes it just has its own line, doesn't it? Come on, calculator. Turn on. Aha! I moved it to my other screen and turned on. So we go to mode. We need to go down to parametric. So par, P-A-R. Go there. So now we have x and y. And so my first one is x equals 4 sine t. Sine t. And my next one is y equals 4 cosine t. Cosine t. We hit graph. Now, once again, my graph is weird, so I need to follow those same 3 steps. I need to hit zoom 6. Don't think you know the answer yet. Follow these 3 steps. Zoom 6, zoom 0, and then last but not least would be zoom 5. Zoom 5. And that is clearly a circle. Woo! Okay, and now I need to do this next one. So I go back to y equals. This x is just equal to cosine t. And y is equal to 8 sine t. So 8 sine t I hit graph. I'm not seeing anything at the moment, so I need to take a moment and follow the same steps. Zoom 6. Zoom 0. And then zoom 5. And what does that look like? An ellipse. All right. So that is the end of those questions, but I said I need to go back and do number 8. So let me go grab it from this paper. Sorry, this is weird. I know I should already have this done. Not professional. But then all the mistakes I make. Anyway, all right. So here's number 8. Let's look at it. Okay, convert the rectangular equation y equals x over x minus 1 to parametric equations using t equals x minus 1 as the parameter. And then it says x equals y equals. So it wants us to get an x equals equation and a y equals equation. Right here I can get my x equation. If t equals x minus 1, I can rewrite this by adding 1 to both sides. So it says x is equal to t plus 1. Okay, so I just rewrote this equation by adding 1 to both sides. So x equals t plus 1. So now I can take this t plus 1 and I can plug in for x here and here. So y is going to be equal to t plus 1 over t plus 1. So I'm just plugging in t plus 1 for both my x's. T plus 1, and then don't forget this minus 1 that's right there. Well, in the denominator, this plus 1 and this minus 1 are going to cancel each other out, so you're going to get t plus 1 all divided by t. Okay? Now, tried to take my time explaining stuff. Again, I apologize that I messed up on the ellipse equation that you need to remember to cut your axis in half and then square it for both denominators. For both the major axis and the minor axis, the horizontal and the vertical, you need to cut them in half first and then square them. I genuinely apologize. I forgot that just totally spaced, okay? I'm not a perfect person. I make lots of small errors, and this is one of them, but I know it's going to hurt y'all, so I genuinely apologize for that, okay? All right. Let me know if anything else doesn't make sense.